Good morning, everyone. Please, let's wait for like 2 or 3 minutes for more people to join.
Don't let me put on your mouth. I'll come out. Yeah. Yeah.
Good morning, everyone. Can you hear me? Hello?
Yeah, we can hear you loud and clear.
All right, good. Good morning,
Yes,
everyone.
we can hear you.
Good morning.
Good morning.
All right, my name is Adam Brown, Business Development Executive with Genex Technologies. As you all know that this is becoming, I can say that it's a culture. So we at Genex Technologies, we're one of the leading solar companies, as you know, not by name, but by the value that we offer to people in terms of product, support, exposure, and then training. So the ninth series of this Genex Product Expose is going to enlighten you and expose you to some things which are challenges that you face on the field there. That is how to choose the right hybrid inverter for your project. So that is what we want to talk about. And I'm here with me, the facilitator, that is the lead engineer, Engineer Kunle Olorunkoya. So it's going to enlighten us and expose us to all these things that we need to consider, what to do, and the precautions to take, and the kind of hybrid inverter to go for. All right, thank you. So over to you, Engineer Kunle Olorunkoya. Okay, so before it comes on, let me briefly talk about Genex Technologies. Genex Technologies is one of the leading solar companies in Nigeria. Our office is at Lekki plus 22 Adebisi Oguniyi Crescent. What do? We major in sales of solar components, inverters, panels, like Canadian solar panels, Jinko solar panels, and Genex inverter, Growat inverters, and some other solar components. Everything you need in this field, we have it, the mounting rails, the accessories, and basically we sell premium products. And apart from that, we also conduct training. In this training, we expose you to the things that you need to know. That we usually, this training is conducted like 3 times in a year. So we call it academy, where we onboard people and we train them on how to install solar, how to design, and how to maintain. And as well, we provide support. What do I mean by support? After sales support, if you have challenges with your inverter, you can bring it back to us. We have qualified engineers and we have a strong room that is dedicated for that, where we do repairs, where we diagnose inverters, and we also do some kinds of engineering training on solar repairs, maintenance, and installations. That is all about us in Genex.
Good morning, everyone.
Hello, Engineer Kule. Okay.
You're all welcome on board. Once again, my name is Kunle Olorunkoya. So I will start right about now. What is a hybrid inverter? I'm sure many of us we are familiar with inverters, or hybrid type is different from just common inverters out there. A hybrid inverter is an inverter that can operate with different energy sources like solar, grid, and batteries, and properly manage them at the same time. So that's just a simple definition of what an hybrid inverter is. Yeah, as we have seen and we know, the key factor to be considered when choosing hybrid inverter is what we want to discuss here. So we have system component compatibility. You must consider that the inverter you want to get is compatible with the solar panels that you have, or the batteries that you have, or the grid, maybe your generator. No, if you cannot make sure that all these are compatible with your inverter, then it could be a problem. It's either the batteries are charged and then they are not charged properly because you don't have enough solar panel, and then you use it. And once you use you drain the battery. So all these three things are very important. The grid connection, the frequency here that we operate with is 50 Hz. So 50, 60. So your inverter too should key into this function. The next one is power capacity. Continuous power capacity. It's important. Can it continuously be giving power, or is going to just shut down at some point? So how is it able to do that? So it's important. Then peak power capacity. That means the highest power that can be taken from the inverter, the peak that it can deliver, the highest. So your load should be within this. So any inverter that you want to use you should know that the capacity of the inverter should be higher than your load. That's what all this. The surge power capacity. We have some appliances that have surge. They produce surge when they want to start, like inductive loads, like pump, like fridge, and some other loads like that. So you should know that when all these are starting, the inverter should have that capacity to withstand the surge when it starts. Not that when the load wants to start, the inverter will just shut down. So all these are important, because if it's not properly sized, that kind of a thing will be happening. Now, talking about efficiency. Efficiency has to do with the quality of performance you get from it. especially when, for instance, an inverter is rated maybe 10 kilowatts, and then the power you can get from it is just maybe 5 kilowatt or anything, or lower than that. So the efficiency should be high. And in terms of a charge controller, we know that it's only MPPT that has higher efficiency compared to others. So it's better to choose an inverter that has inbuilt charge controller, and the charge controller has to be MPPT, so that you can extract virtually like every generated power from the roof. So that's what it means. Then in terms of the inverter efficiency, there shouldn't be a lot of loss. When the inverter is working, you should be able to deliver close to its maximum capacity. So that's it. Now, talking about the inverter features, I just mentioned the inbuilt MPPT now. It's very important. It's a key factor for you to consider. Inbuilt charger, which is utility charger. It's not every inverter that has all this. Some inverters are just inverter. They just take energy from your battery, from the storage, and then they cannot restore it. So an hybrid system, a complete hybrid system, will have the solar charger in it, which is the MPPT that we're talking about. Then it will have inbuilt utility charger, so that when utility comes into it, it will be able to charge the battery. Still the same inverter that is the one that will manage everything. So the waveform of the inverter, which complies with virtually all electrical appliances, is sine wave. I'm not saying other modified sine wave or other inverters don't work, but they have their shortcomings. They may be cheap, but some of them eventually would destroy some electrical appliances. So, but pure sine wave is just like your grid supply, which is pure sine wave as well. So it works without any concern. So transfer time is another thing. It depends on what you want to use the inverter for. If you want to use it for ATM machine or some high performing internet stuff, you need inverter that has a very short transfer time or zero transfer time. There are inverters that has zero transfer time. You cannot notice anything. But the line interactive inverters have a transfer time of about 15 milliseconds. It's also short. So you determine what you want to do with the inverter, and then you choose appropriately. Overload shutdown protection, a good inverter should have that. Maybe overload comes by mistake, then the inverter should not get damaged. You should only shut down and show overload, then come back on again, depending on how the program inside is. Some inverter will shut down and they won't come back on. Depends on what you want. You can as well program it. That, okay, when you shut down, just shut down until I come to reset. Or when you shut down, after some seconds, try to come up so that the inverter, the system, nobody needs to go to the inverter. That is complete automatic operation. Short circuit protection. Maybe there's a socket that is bad and now cause short circuit. The inverter should not go bad outrightly. It should just show short circuit, shut down, and then it comes back on. Or you go and restart it, then it comes on. Over temperature protection, in case the environment is high, it should be able to tell you that I'm not comfortable here. This environment is high in temperature. Then you know what to do, whether you provide external fan. But the inverter should have its own cooling system. It could be natural air, it could be liquid, it could be fan. So different depending on the type of inverter. So that is it. Battery management system function. The inverter should have capability of managing different types of batteries. But the type of battery that you want to use with it, the inverter should be able to manage it well, charge it properly, and discharge it according to the program you put in it. So if you can say, okay, I don't want my battery to get discharged over beyond the 50% DOD, the inverter will do it for you. So you should be able to charge, and combining solar and make the solar priority, and all these functions are inside the inverter. So cooling system versus noise level. Some people don't like any noise at all within the environment. But some inverter have fans, and this fan, when they are working, you may not know. But some, because of the capacity of the inverter, the fan may make a lot of noise. And some people don't like it. So they may complain. So choose the inverter that you want. Some don't have fan at all. So that's it. Remote monitoring is another function that allows you to check what's going on with your inverter, and then you can preset some values. That, okay, oh, I want to set some parameters. You can do them remotely on the inverter. So the next one is a brand consideration. I think it's important for everyone to make a research to look for a good brand that will not be giving you problem. You check online, check everywhere, ask your friends and family, oh, have you used this before? Just make your findings. Then you now determine which one do I need to go for. So that's just about brand reputation. The inverter that has been out there, that is working well, and many people know about it. What is the brand name of such inverter? Is it Genex? Is it Growatt? This is Genex Technologies, and we have Genex as our first brand. Other brands that we deal in, they are there. Warranty and technical support, which is very important too. Make your research, find out, engage the company, know about the warranty terms and conditions. Is it friendly? Then the technical support. Is it, do they support technically when somebody's on site, or the information that is required so that you don't make mistakes? Apart from the details in the manual, you know, to make your installation fast, at times you need technical support. Something happened, you may not even be with the user manual, and you just need to call somebody, oh, I need this, and you are giving at the spot. It makes you happy. You need to find out about that concerning the brand you want to get. I think it's important as well. So end user stroke site consideration. Now, you as somebody who is making this research, you need to, okay, the usage pattern, you know how you want to use it. The usage pattern means how do you want to use it. Some people install inverters just for afternoon use when their children are back from school, instead of burning fuel. They just want them to, okay, the lecturer or their teacher wants to, or they want to watch film, all these cartoons and everything. During that period, they don't want to wait. Since it's only television that wants to run, you know, it's economical. So, or your own is that you want to use it overnight, so that when you don't, you know, when you want to sleep, you don't want noise anywhere, you don't want to use generator, maybe NEPA can go. When NEPA goes off, or your public utility supply is off, then you have your inverter to just come up and then power your fans or air conditioner for you. Your freezer may be running out, you know. So that is your usage pattern, and it's important to define that. That will help to really have the old size well programmed. Then building roof pattern too. It will determine the type of inverter you want to buy. If your roof is one that has different directions, that this one face south, this one face north, this one, and you want to put solar panels, and then your one string cannot be on a platform where it can, the old string can generate at the same time equally, then it's a problem. If you use high voltage inverter, then you'll be wasting energy, because one panel facing one direction will cause others to generate low. If that one panel is seeing low generation there. So it's very important to know, oh, if your roof is facing different, you choose a low voltage this is so that whatever they see in different direction they are facing, if you cannot help it, you know, they will contribute it and deliver it to your inverter systems and your storage. Then your budget, you need to work out your budget. What's your budget? Is it 10 million inverter you want to solar power system you want to put in place? Or I don't want this thing I want to do now, I don't want the one that is more than 5 million. You put your budget and revolve around that. So, okay, how long does it last? What's the backup time? What are the loads that will be on it? By the time you make your research, you get to a point and then that you like, at least you manage it. Mind you, inverter system is just a way to economize energy. So that you want to economize your public supply, you need to put such a thing in place. What's the last? Okay, then scalability, which is close to your budget too. Maybe, okay, let me do some now. Let me do maybe 5 kVA this year. By next year, I will increase it, or in the next few months when I have the money, I will increase it to 10 kVA. It's achievable. So which is important. You consider all this as we are trying to get the best solution. Now you can ask questions. Thank you.
Thank you, Engineer Kunle, for that wonderful presentation. I believe that some of us, if not all, we have one or two questions to ask the facilitator. But in my chat, I already have like 3 or 4 questions. So number 1 question says, if you know that you still want to ask questions, please signify, or you send the question to your chat. You can send the question via the chat, or you signify by raising up your hand. Let me go to the chat quickly because of our time. There are some questions there for Engineer Kunle. Number 1 says, how can one determine if an inverter is a pure sine wave? Is there any way to determine aside the sticker?
Okay, yeah, that's why it's good to choose a reputable company. It will be stated in the user manual. And if you have an equipment like oscilloscope, there are pocket oscilloscope. I know it's not everybody that has that. Once you put on the inverter and you connect to it, it will show you the waveform. But it will be, if you don't want to go through that route that you need to go and get oscilloscope, get this, get that, just follow what is written in the manual. Go through the details, ask the company. Is always stated. If it's not put on the sticker, it will be in the manual. This information is not something that should be hidden. So it's out there.
Okay. Extreme Mutual. Is that clear? All right, let's go to another question. Please, sir, I need more clarification on the building roof pattern. I don't understand the question, right? But Engineer Kunle, maybe you understand it better. The person says, please, sir, I need clarification on the roof pattern.
Okay. Yeah, we know that we have different buildings with different roof shape. Some buildings are having flat roof, everything is just flat, inclined to one side. That type of roof, you can use high voltage inverter on that type of, because all your panels will be facing one direction. There's no way one panel can generate lesser than the other one if they are all the same capacity. But we know that some roofs have like the roofs are facing like 4 different sides. You have the one facing right, one facing left, one facing front, one facing back. If you go outside the building, you look at different buildings, you understand this that I'm saying now. So that type of roof, if it's not possible for you to put a string, complete string on a side of the roof, then don't say, okay, for instance, you want to use 10 panels in a string. You already have 8 on that platform that is facing the right direction. And then the remaining 2, you don't know where to put it, and it's just one string. You now put it on the other side. Because you have done that, if the normal direction, which is south, or whichever that platform that you put, or the major number of panels, is seeing sun very well at that time, and the other one is not seeing the sun because it's not facing where others are facing, that particular 2 that are facing the other side and are not seeing where they will generate well, will cause the remaining 8 to generate low. If you have 200-watt solar panel, all of them, there are 10, and 2 are facing side where they won't generate well, and the rest are facing where they will generate well. Yet, because the 2 that are facing where they won't generate well can only see what will make them to generate just about 50 watts, all other panels that are connected in series will generate that 50 watts. You see, you have wasted energy. That is the reason why all the panels that are connected in a string must face the same direction. I think that is clear enough.
Okay, thank you very much, Engineer Kunle. There's another question here too. Why most of hybrid inverter, their MPPT charge controller, they are not good? Okay, I think what this person is trying to say, that is Abdul Hakim Gambo, is that why are inbuilt charge controller of some hybrid inverters not good?
Well, it depends on manufacturer, and it depends on the type of MPPT that are there. If the person is referring to MPPT now, which is the high efficiency charge controller, if it's not good, is the design. That's the manufacturer error, or manufacturer is a problem. You understand? Every MPPT needs to work well because they give specification, unless if the installer is not following the instruction, because there is specification for everything. If there is an instruction that says this MPPT is to operate within this range, and you exceed that range and it goes bad, it's not that the MPPT is not good, but you have gone beyond the instruction given. Or they say it will start seeing solar at 60 volts, and you put solar panel that we just the maximum generation, at maximum generation it will give 60 volts. You know, you won't get anything, because your solar voltage is supposed to go beyond that point. So just work within specification and instruction. Then I believe no manufacturer will want to roll out systems that will be giving problem, then they will be returning it. They won't have time to do. So if there's no mistake from installer or anything, then I think most MPPT are okay.
Okay, thank you. There's another question here for you too. Is it advisable to use transformerless hybrid inverter to power fuel pump, since it will always require high starting current each time it is engaged?
Okay, that's a good question. That is where technology is driving us to. If it's even possible not to use transformer at all, these people will have them out there. So each inverter has surge handling capacity. That's why I mentioned it. That's the surge capacity of the inverter. You need to look out for that. For instance, our inverters have ×2 the capacity. That's the surge handling capacity. If our inverter is 5 kilowatts, the surge handling capacity is 10 kilowatts. So which means you would have factored in your pump, know how many inverters will be able to cascade. If one can do it, then you go ahead. If the starting current is within the surge capacity, then you are good to go. But if it's beyond it, then the inverter is going to shut down. Even transformer base too works the same way. They have surge handling capacity. So it's just to look out for that, and that's all. We use it for pumps. Many filling stations are using it, and they have highly inductive load that have starting current. Many companies are using air conditioners, and it's possible for 2-3 air conditioners to start at the same time, which gives a high starting effect. You know, if the inverter is not capable to power them, it will shut down. So it's just to size it well. That's all. I think that answers that question.
Okay, thank you very much, Engineer Kunle, for that question. Answered well. Okay, do we still have questions here that we've not touched? Okay, I don't think we have any. Please, if you have questions to ask, okay. All right, Mr. Ali Ibrahim, go ahead with your question, please. Unmute your mic and go ahead with your question.
Okay, thank you very much. Thank you so much, Engineer Kunle, and thank you so much, Genex Technology. It was indeed an insightful and impactful session. I really enjoyed every bit of it. Mr. Kunle, because of time constraints, I do really appreciate your genuineness in handling those questions which have been raised by the participants. It's really an eye-opening, and thank you so much. So my question is that you wanted to connect a system of inverter that they are not in line with the maker, that is the model, but their capacity are the same. Like for instance, you want to connect a glow-wet inverter, connecting it with the GM's Linux inverter. And then you have another alternative. Like now I'm on the site now, I have another alternative, which the site now where they have the inverter the client have is Johanna inverter system, which is 7.5 kV. And he wants to reduce costs, but he need an improvement in his own capacity to over 15 kVA. And now we have go-wet inverter being installed to him in series of it. But now this 7.5, which he has already now, he still wants to utilize it so that he can be able to have a full capacity. But now, right presently now, I'm at the site. We are now using it on a load separation unit that the 7.5 we have initial, we use it to load 7.5 to the system, while the other one now, which we have already procured and installed, which is the go-wet inverter, we having it to be of 10 kVA, that is the three of them. Now, if we are to reduce the cost of this person now, loading these 3 go-wet inverter in one for the lightning and then for the switches, Then this other 7.5 is just going for the fridge, the refrigerators, at the same time, the AC. But we don't want it to be a double margin. Can we be able to make them to go in serial? Is it possible? That's my number one question. And number two, there's a device which has been recommended, but it's not, I've not yet verified it, whether it's authenticity, that it can be able to match and switch them at once. Instead of switching the Yaoma inverter first, which will power only the refrigerator line through the power cords, at the same time powering the this thing, the AC. But now this growth we invert, which we have already put over, now we take care of the lighting, the electronics within all the system. So we don't want this thing, but these two devices are being integrated to it that we'll be able to click on that is going to start both of them automatic. Is it advisable to do that? But this is just something that we are going to put on a test. This is the first one we wanted to do on a test. Is it advisable we go on using this switch to test run on it? Thank you so much, Mr. Conley. Really appreciate it.
Okay, you're welcome. Your first question is if they can work together at once, being synchronized. I guess that's what you mean. But
yes, sir.
Since they are not from the same manufacturer and you don't have specifications anywhere that says they can work together, you won't be able to do that. So that is out of it. Then whether the other you can switch at the same time, if they are powering different locations, it doesn't really matter that you should switch them at the same time. You can switch them at different times when the loads are there. When they want to use the load, that's when they will switch it on. Are they operating on same bank of battery?
No, I separate the battery system.
Okay.
Yes.
So each group, each system with its own storage should face its load at any time they want to use it. Let it work with the load. Of course, you know the loads and you know the power, you know how it's going to operate, whether in the night and everything. So if they need additional components to upgrade that particular group or unit, then that will be done separately. You can have 3 groups of inverter, even 6 groups in a place. If it's a big place, maybe a company, and you have grouped all their loads into 3 phase, all these loads will be on this group of inverter, all this group will be on this. You can do it like that. And if you don't want that, you want a singular inverter that will power everything, then you have to replace with that particular singular inverter that has the capacity to do that.
Okay, sir.
I think that answers your question.
Yes, that answers my question so much. Thank you, Mr. Conley. Thank you so much.
You're welcome.
Okay, so we still have some questions in the chat. Another question says, sir, do low voltage AC or inverter AC have startup surge current?
Low voltage AC or inverter AC start up surge current. Well, inverter AC, the reason why they designed them is to eliminate that startup current, which is the surge current that we're talking about. But their consumption is still the same. 1 horsepower by standard is 1 horsepower. Unless you put some measures into place. Maybe they say, okay, this air conditioner has a turbo function, it has this function, and you program it according to the manufacturer specification. Without that, if you just leave it to run by standard, it's the same consumption. It's only the difference is that normal old AC has startup current that could be ×2 or more of its own capacity. So low voltage AC, I don't know which one is low voltage AC. Maybe it's referring to normal normal old inverter, old air conditioner, like national Panasonic, all those old ones that just have heavy start-up current. I think that answers that question. Okay, this is another question here. What if the chain of panels is wired in either parallel or series parallel? Will it give a better voltage or power output? Well, power in equals power out under normal ideal case. So if you are, whether you arrange panels in series or parallel, the total power is the same. For instance, you have some panels, maybe 5 panels now, each is 200 watts, and you connect them in series. You know the voltage is going to increase. That means you want to use a high voltage system. So the power remains the current of each solar panel times the voltage multiplied by the number of panels. That is the voltage of each solar panels. So the overall voltage times the current that flows, that is the power. So if you connect them all in parallel, the voltage will remain the same, while the current will keep accumulating. So you now multiply the current by the number of panels times the voltage. So the same power is what you get. So it now depends on you, which one do you want, based on the conditions surrounding you, whatever. So series, parallel, so far you match them well. I think you are good to go. They give you enough generation. They give you enough power output. That's all. I think that answers that question.
Okay, so thank you. Another question here says, for a 5 kilowatt inverter, what is the maximum PV array power that can be connected? For a 5 kilowatt inverter, what is the maximum PV array power that can be connected? This person is trying to say that they need to use the power from PV to power all the loads, and at the same time use the power to charge the batteries during the day.
Okay, everything boils out to the specification of the inverter you have. If the inverter says that the MPPT capacity is 4,000 watts, it means from solar panels, you cannot get more than that 4,000 watts. If you like, put many panels. Of course, you don't need to oversize. Be sure of your sizing and the type of the model of inverter you are using. So if it is 4,000 watts, the inverter cannot deliver more than 4,000 watts. And that 4,000 watts includes your load and battery charging. So you should size within the capacity of the solar if that's all you have to manage your battery. Your load may be 1,000 watts, and then the battery capacity may demand for 3,000 watts. So that balances if you want to use it at maximum, or 2,000 watts. So it depends. Just make sure that whatever you are doing, both load and the battery power that required charging power is within the capacity, maximum capacity of the MPPT charge controller present in the inverter. Thank you.
Okay. Another question again. Sir, what is the implication of using a single phase inverter where you need to use a 3-phase inverter? And please explain in details the difference between single phase and 3-phase inverter.
Okay. The implication of using single phase inverter where you are to use 3-phase comes up, and it depends on the appliances that you want to power. If you have an appliance that must be powered with 3-phase synchronous, synchronous means the 3-phase must be present, and they are not in phase. All the phases are not in phase. They are no. If you need to understand synchronous and then just single phase is different. So if there's a machine that must operate on a complete 3-phase power, then if you don't give it to it, it's not going to work. Some of them even have some protections that if you supply one phase, it will shut down. If you connect single phase that is not synchronous, that you have single phase, you just now connect them to phase 1, phase 2, phase 3 of the system, it's not going to work. So that's just the implication, and it can damage the appliance. It may not damage the inverter because the inverter is just to give output. If there is overload, it shuts down. But for the appliance you want to power, you must be sure that it is not an equipment that must be powered with 3-phase synchronous supply. Then it's asking, what's the difference between 3-phase inverter and single phase? A single phase inverter will only give an output of just maybe 220 volts between live and neutral, and that is all. The input also is live and neutral, which is single phase. A 3-phase inverter will take line 1, line 2, line 3, and neutral as its own input, and is going to generate as such. The output is line 1, line 2, line 3, and neutral for the output. So it's 3-phase in and out. So, and if it's not complete, if you have a supply from grid and it's not complete, the inverter shuts down and go back to battery. Because the 3-phase supply must be complete before that such inverter will use it. If 2 phases are available, it won't work. If only 1 phase is available from the input, it won't work. It won't charge your battery. And it won't give output from the available. It will rather go back to battery and use your battery to deliver output for you. So you can see the difference between the two of them. Thank you.
Okay. Because of your time, so we'll be asking like 1 or 2 questions. But there are many questions here, technical questions. Sincere apology, we will not be able to attend to all because of our time. Well, Engineer Kule, someone is asking that, is it compulsory to switch off solar current if he wants to charge with generator or grid?
No, it is not compulsory, because they have designed the hybrid inverter to make use of free energy from the sun first as priority number 1. So if you switch it off, that means you are not economizing anything. For instance, if you are using grid, that means your bill will keep increasing. Then you'll be using the whole energy to charge your battery, which is not economical. Even to many people that are rich out there, they are using inverter system. They prefer to reduce their cost on utility by putting solar panels there, so that when 2 of them are available, the inverter chooses the solar first. Whatever remains for the load or battery to use, then will now come from utility supply. That's the way it works. And then you can still work around it by, if there is a special case, you can configure the inverter for your tastes. Maybe you don't want it to work during the day, you now want it to accept utility in the night, and when you accept utility, it should not charge at all. So all these programming are inside the inverter. You can use that to your tastes. Thank you.
Okay, all right. Lastly, what is the difference between high voltage? Because I can see that this person does not understand it. It says, what is the difference between high voltage inverter and low voltage inverter? So from the example given, it says 10 kVA, for example, 10 kVA 96 volts versus 10 kVA 48 volts. And how do we select it appropriately for our project? if I'm to use the same number of battery?
Okay, when we said high voltage and low voltage, we are referring to the solar voltage. Some inverters have their maximum solar input voltage to be 145 volts. And the minimum could be maybe 30 volts or 50 volts or 60 volts. So they work within that range. The one that is high voltage will be from 120 to 1000 volts. Another one is from about 120 or thereabout to 500 volts. All those ones are categorized to be high voltage solar input. But in terms of the battery, yes, we still have low voltage and then high voltage, but it is good to operate within the range of voltage that is common. We have 48 volts as common. Many inverters operate on 48 volts, 5 kVA, 10 kVA, they operate at 48 volts. Even some, many of these lithium ion batteries, they are 48 volts. So it's better to operate within the common voltage for your inverter so that you don't run into trouble when a battery is failed. If you are using a lot of batteries in a string and then one fails, the system shuts down. But if you have like 48 volts and you accumulate them in parallel, if one string fails, other strings will still manage your system for you. So I think that's answered that question.
Okay. I think there's another question here, Engineer Kule. Sir, is it okay to use the total solar wattage designed for either growers or Genex hybrid inverter?
Is it what? Yes, it was designed and it was stated in the manual that this is the capacity of this inverter. It is left for you to say, okay, I want to operate at that maximum, but it is not always good to operate at maximum of any electrical or anything. It could be a car. For instance, if you have a car and they say speedometer is 350, is it okay to be running at 350 kilometers per hour? You have a generator that is 100 kVA. Is it okay for that generator to be running at that 100 kVA? That means it's not going to last. So if an inverter is to deliver 4,000 watts at its maximum, you may be operating at 3,000 watt, 3,500, according to your design. But in case of some time, maybe something happens and the inverter needs to now deliver that power, it's just occasionally. That doesn't mean that you should be operating continuously at maximum. Of course, if you operate at maximum, the inverter should not go bad. And if anything happens, it depends on the company where you buy it. And then we'll look at your sizing. You know that if you put 4,000 watt solar panel as given in the manual that, okay, this inverter is 4,000 watts, and you put 4,000 watt solar panel, you won't be operating at even 4,000 watts at the peak. Unless you now put a lot of panels to get that 4,000 watts. I think that answers that question.
Okay. There is another question here. I think someone is raising up his, and can we still entertain it? But because of our time, we'll soon be cut off. We might not be able to entertain further questions. But you can please send your questions to adam@genextechnologies.com. I say again, adam@genextechnologies.com. If you have some questions that have not been treated, then I will quickly forward it to Engineer Kunle, and Engineer Kunle will reach out to you. So thank you very much for this wonderful edition. We believe that it is very important, and it will also help us in choosing the right hybrid inverter for our installations. And not only that, the questions that have been treated, I know that we cannot go again and commit errors with it. So Engineer Kule, the facilitator, we say thank you very much, and some other Gen staff, we say thank you very much for the wonderful session. God bless you all. Bye. We will see you next time.